So hi guys, here this lecture will be discussing about the law of conservation of momentum. So under uh, the subunit flow characteristics, so as we know that when the fluid tends to flow, it has to have some a mass. Then if the mass of fluid tends to move, it needs an energy. So when it flows, it will have a momentum. So here you're going to find what is the momentum in a flowing fluid. So this momentum equation is based on law of conservation of momentum. So or on the momentum principle. It states that the net force acting on a fluid mass. So this is a net force acting on a fluid mass which is equal to change in momentum of a flow per unit time in that direction. So change in momentum per unit time in that same direction. So whatever the force which has been applied in the direction, so there will be some change in momentum in the same direction. The force acting on a fluid mass is given by Newton's second law of motion. So this has been derived based on Newton's law of motion, which is equal to force which is equal to mass into acceleration. So acceleration will be change in velocity with respect to time. So force will be mass into change in velocity with respect to time. So here the mass is constant, we are not changing the mass, so the m can be taken inside the differentiation. So F which will be equal to change in momentum with respect to time. So if we take the dt to the other side, so F into dt which is equal to change in momentum. So this is said to be an impulsive momentum equation, which means that a certain impact force. So if we give a certain impact, there will be some momentum change in momentum. Okay, so due to sudden impact, there will be some change in momentum. So for example, so if you push the water in a pipeline, right? So for example, if a water sink is being clogged, so if you have give some external force with the help of a plunger, so that impact force actually takes out or clears the clog inside the sink pipes. Okay, so that's an impact force. So that's how the plunger actually being used in a sink to clear out all those clogs and stuffs which has been clogging your pipelines. Right. So this above equation is said to be an impulsive momentum equation. So here we're going to find what is the forces present in x direction and y direction. We're going to find, and so force exerted by the flowing fluid on a pipe vent. So here consider sections in a pipe vent. The component of force exerted by the vent on flowing fluid in the opposite direction is minus Fx minus Fy. So F is a force, so X is the direction, Y is in the Y direction. So the forces in X direction is minus Fx, which is an opposing force. Y direction is minus Fy, which is opposing force in Y direction. So it's a pipe bend. So you would have seen on your day-to-day lives on your house commercial pipes, right? So these are the bends. So the bends will have a bend at certain angle, maybe 30 degree, 40 degree, 45 degree, it depends. Okay. So P1A1 is a pressure force at section 1. So this pressure force is given to move the fluid. So when the pressure force is given, we will probably have an opposing pressure force. So and the force on the direction also. So the opposing force will be P2A2, but it is at certain angle. So we're going to resolve them into horizontal component and vertical component. So horizontal component are said to be cos theta, vertical will be sin theta. So P2A2 cos theta and P2A2 sin theta for horizontal and vertical component. Same as V1 will be the velocity of fluid at section 1, V2 will be the velocity of fluid at section 2. Again it is at certain angles, so we're going to resolve them into horizontal and vertical component. So horizontal component will be in terms of x direction, vertical component in terms of y direction. Right. So now the force acting in the section 1, P1 A1. So now the net force acting in x direction will be equal to rate of change of momentum in x direction. This is the net force acting in the direction of x will be equal to change of momentum. So forces are P1A1 minus opposing force in x direction, so P2A2 cos theta, because it's in a horizontal component, so it's an already inclined, so horizontal on the x direction, so this horizontal, so x direction, so P1A1 minus P2A2 cos theta minus Fx, so which is equal to mass of fluid per second, so rate of change of momentum, so change in mass and change in velocity. So mass of fluid per second we called as a flow rate. So volume flow rate or mass flow rate per second, so it's a kilogram per second, so it will be a discharge. So for example 1000 kilograms of liquid or 1000 kilograms of air per second we called as a discharge. So which will be equal to density into Q. So it's an for a common fluid, so it might be compressible or incompressible fluid, so we need to consider about the density also. Rho into Q into change in velocity final minus initial velocity. So initial velocity is v1, final velocity in direction of x will be v2 cos theta, again it will be in the, so v2 cos theta minus v1. So to simplify this, f of x will be equal to this value. So this is a formula to find force in x direction, the force that is being required to travel your fluid. So momentum equation in y direction, again same whatever we have done in x we're going to find. So force which is equal to change in momentum with respect to time. So the force is in y direction, but the big section 1 we do not have y, so it's a horizontal. From here it tends to go, so y direction, there is no y direction, only x, so the initial force will be equal to 0, so 0 minus opposing force is P2A2 sin theta, P2A2 sin theta minus Fy is equal to change in mass with respect to time, which is mass flow rate rho Q into change in velocity, final velocity minus initial velocity, final velocity in terms of y direction v2 sin theta. So on x direction we doesn't have on inlet we doesn't have a y direction because it's only travels in x, so it will equal to 0. So if we simplify this, f of Fy is a force in y direction we can able to get. The resultant force f of r will be equal to f of x square plus f of y square. So it's a simple a trigonometrical way to calculate the resultant force. So theta will be equal to tan theta will be equal to Fy by Fx. So again we use trigonometrical methods to find this. So that's it. Thank you guys for watching.